Hi, my name is Blake Arnold,
And I'm Tori Plana.
and our senior project is on the Systems Optimization Club. So here's our problem statement. We noticed a large problem in small to medium-sized enterprises where there is a lack of industrial engineering practices applied to their processes. This could be from either an absence of IE knowledge or just a lack of financials to hire on consulting services. Also, SMEs don't have people to spare, even if they want to solely dedicate an employee to introduce lean ideas into their process. In our presentation, we will be talking a lot about small to medium-sized enterprises, which we will continue to refer to as SMEs, so keep that in mind. On the right, we have a few pictures of bad IE practices, a horrible spaghetti diagram, warehousing that could use some 5S, and another mess of a warehouse. These are all examples of processes we would be able to fix.
So as Blake was saying, many of these IE consulting services are absent because they address the larger enterprises where there's more profit to be made. So there's a lot of potential to improve the bottom line of these smaller and more local small to medium-sized enterprises. And from there, we can help them expand and develop their business to further their potential. So our vision is to be able to provide a cheap and mutually beneficial consulting service that will allow local SMEs to optimize their industrial processes.
So for our senior project, in creating the RL Plana Consulting Company, we wanted to create a project charter, which is one of our deliverables, and that highlighted key milestones and project deliverables that we'll have. These include completing the lit review, contact and do test runs with your manufacturer, reports, and then also the deliverables would be business model canvas, work breakdown structure, Gantt chart, lit review, and test run and report out.
We developed a business model canvas to lay out key aspects of our company. It's important to note our dual customer segment. We need to satisfy both students working with us and companies who we consult. Our value proposition to companies is to lower costs while increasing productivity, efficiency, and effectiveness of the system at an affordable price. Our value proposition to students is to provide projects that pertain to students' current classes, allowing real-world experience and helping make better career choices in their future.
So next we created a Gantt chart to help us manage the creation of RL Plana Consulting throughout the rest of the year. We did so utilizing Microsoft Project, which is a software that we learned in IME 303, which is a project management organization. So now because we have had to pivot, which Blake will speak more about in the next slide, we had to change many of these activities, yet the general pattern of them, contacting manufacturers, creating projects, and so forth, were much the same, which we stuck to.
After our initial formulation of RL Plana Consulting, we realized upon graduation we both wanted to secure jobs from established corporations. So forming a new company would not guarantee the success of our value propositions. We decided the best way to keep our values was to create a club at Cal Poly. We created the Systems Optimization Club, where students will be given projects from various local SMEs. For students, it builds their resume, allows them to network, gives them industry experience. Also, potential internships could line up, and the project could act as an extended interview. For SMEs, it's cheap consulting work, such as standard times, flow process charts, etc., and an increase in their system optimization.
So when we were RL Plana Consulting, we hit a roadblock when reaching out to local companies. We were simply being too vague with what we had to offer them. We wanted to do consulting work to help their manufacturing processes, but they did not know what they needed help with since they were not actively looking for consulting work, and we did not know exactly how we could help them since we are not familiar with their processes. So what we did was we decided to focus specifically on offering standard times. Every company needs to know how fast each step in a process takes, and this can help improve its efficiency by focusing their attention on longer tasks in terms of reducing their times. So we would say this, and all of a sudden we started getting calls back, we started getting more emails, and just a general interest in our club. Doing this right will help establish credibility and a good introduction for our students into the kind of work we perform in industry as industrial engineers. So from here we are able to understand their processes, and then we have established a relationship and trust, and now we can make further suggestions and work in new areas of improvement.
So this is the design of our club. Each project has an officer which all the club members report to. The officers then report to the VP, who reports to the president to oversee all projects. We also have an external relations chair, which handles contact with manufacturers, internal relations, which handles club events, fundraising chair, which handles sponsors, and a treasurer and secretary with typical club duties.
So after contacting many manufacturers and receiving a lot of interest, we decided to go with Zodiac Aerospace's Cabin Interiors Division and Hydrogen Junkie as our 2 test pilot projects for spring quarter. Blake and I took tours of both facilities, gained a general overview of the projects that were to be involved, and then assigned individuals to teams and different projects based on experience, age, availability, and interest. And so in Zodiac Aerospace, we have about 22 students working there currently on 7 different teams, and we have 2 to 5 students per team and 7 project managers. Hydrogen Junkie consists of 3 students and 2 different projects. Once elections happen, chosen students will be contacting these manufacturers to set up projects with them.
The first project we took on was Hydrogen Junkie, a one-man operation out of a garage. Jerome Law makes hydrogen fuel cells and sells them to a vendor in Cayucos. When we toured his facility, we noticed a lot of room for improvement. Implementation of 5S, wasted movement, misplacing tools, and no standardized process. Sometimes he was even wandering from workstation to workstation with no set purpose. He also spoke of creating a new facility in a shipping container to contain his process and movement. Our vision was to create that shipping container with a standardized process and reduced movement.
So for the Standard Times project, we mapped out and recorded the fuel cell creation process, which consisted of 108 activities and 10 trials of each activity. And from this, we found that the total standard time is about 2.5 hours, with the longest task being drilling of the plastic plates and final assembly. We also forgot to mention that Jerome is a paraplegic, and since he wants to add on 2 other employees to certain steps of the process, we added allowances for those times.
Here is the spaghetti diagram of Jerome's movement. Most of his tools are spaced very far apart. He moves back and forth unnecessarily when he forgets tools, and there's a lot of clutter and obstruction in his way. His facility is actually in his garage, so there's a lot of unnecessary movement he has to complete to get through different parts of his process, and a lot of different storage that is not necessary in his facility.
So one of Jerome's dreams is to be able to travel around the world while still being able to work. So we drew up this facility design for a shipping container that he would be able to use as a workspace. The open walls are necessary for ventilation when powering the drill press, and the air hose hangs down from the ceiling. So underneath of that, there will be a generator that powers the electrical equipment. And the ramps are for easy access for him to get into his workspace since he is in a wheelchair.
Here's the movement of our standardized process we put together. As you can see, compared to his old facility, there is a lot less movement. Also, we've reduced the space between workstations, which reduces the total time. After cutting out all the non-value added movement, the expected standard time would be 90.5 minutes, which is a reduction of 70.5 minutes. We can further reduce the standard time if we consider other alternatives. We determined Jerome can order the plates and gaskets pre-drilled. If he does, it could reduce the total time by another 42 minutes, which would equal 48.5 minutes to complete one fuel cell.
So next for Hydrogen Junkie, we're going to keep working with Jerome to help improve the standard times of the fuel cell creation process. And then we also want to add employees to the process. Jerome doesn't want to be doing all of this by himself. He wants to have 2 additional employees to help with some of the more difficult tasks that are required of him since he is in a wheelchair. And then on top of that, we also want to integrate new students into the relationship since Blake and I aren't going to be here next year. So we'll introduce him to the new students that will be coming in from the Systems Optimization Club.
Now we're going to talk about our Zodiac Aerospace project. We are working with the Zodiac Aerospace Cabin Interiors Division, specifically an alumni out of Cal Poly Industrial Engineering, Pat Brennan. Myself and Tori were the officers for this project. There are 22 students on 5 different projects at Zodiac. There's 7 different project managers from those students, and now we're going to go on about the projects and descriptions. 7 projects?
So we began setting up these projects at the beginning of spring quarter, mainly communicating with Patrick, Brennan, and then our other contact, Chad. Blake and I were able to go down and visit Zodiac Aerospace, where we received a tour of the facility and an outline of all the projects. And then we came back and talked to our club, and we got an interest list going of all the students that wanted to partake in the projects, their work experience, or the project experience, their grade level, what projects they're interested in, and so forth. And we were able to divide them up into the 5 teams, as you see here. Team 1 is responsible for working on the A380, which is the biggest double-decker commercial airliner in the world. And so they were specifically working on value stream mapping and workstation redesign for the electrical testing section of the manufacturing line. Team 2 was working on standard times for the brand new Honda Jet, which is a private charter jet that is not yet coming out.
Team 3 is working on the 5S shipping, which is the outgoing products of one of their warehouses. Team 4 is working on Ergo workstation and redesign of the A380 as well, but a different workstation than Team 1. Team 5 is also working on standard times of the Honda Jet, but a different set of products.
Currently, all of the projects are going very well, and they're most likely going to continue into fall or pivot into new projects depending on which students want to continue working. So a few roadblocks we've run across since working with Zodiac Aerospace, mainly communication issues with the manufacturers and our representatives over there, specifically because Zodiac Aerospace is 40 minutes away, so we've had some trouble in communication since it's all been through email and calling. They're also just really busy, doing their everyday job, so it's been tough. And then another issue we have been having is coordinating schedules between the students, and then on top of that, coordinating those student schedules with our manufacturer. So it's really hard to set up times that the students can get down there and then that our representatives can be available. Also, attracting new students for the new projects, that's going to be a roadblock in the future. We need to keep adding students to the club and making sure that they're interested in continuing these projects. And then also we've been having issues with standard times, as said before, because of the fact that some of these tasks are extremely lengthy.
So what's next for Systems Optimization Club? We held elections and we have a full board going into next school year. Marketing to new manufacturers and students needs to happen, so we keep gaining projects and students into the club. Continuing relationships with Hydrogen Junkie and Zodiac Aerospace, so we have to continue those projects which we've started, and if there is potential for more projects in those companies, we'd like to continue that relationship. Also, open up the club to all enterprises, not just manufacturing. That means recruiting on students from different majors and adding that to our bio as a club.
So that concludes our senior project presentation. Once again, I am Tori Plana.
And I'm Blake Arnold.
And thank you for listening.